So, to understand calculus, we should basically have an idea of the concept of functions. So, what is a function? So, what you have studied using a set language, a relation between two sets where one is called the domain, the other is called the codomain, in which each and every element of this set is related to a unique element of the codomain. So when you have an element x, then the image of x is what we call as y, and the relation that maps A to B is generally called by f. So we'll say y is the image of the variable x under this relation f. So if each and every element of the domain is related to unique element in codomain, then we say this relation is a function. So this is very basic. So how we could think about it is, a function is basically a relation between two variables. What functions we discuss in calculus is all real valued functions. So the domain is real and the codomain is also real. And you know real numbers are uncountable. So we can't write such elements of real numbers in discrete matter. It is continuously available between any two given numbers a and b. So each and every point on this line corresponds to a real number, and each and every real number between a and b will be there in this straight line. So there are uncountably many real numbers in any given interval. So what we discuss is a function where your domain happens to be real and codomain happens to be real. So all these diagrams and basic knowledge of functions required, but we can't get along with this in calculus because we study only real valued functions hereafter. So for example, if I say x is related to x square, so this is x and this is f of x. X is mapped on to a relation whose value is square of x, and I shall name this function as f of x, or you can call it as y. So y is same as f of x, both are same, and f of x is x square. So each and every value is mapped on to its square value. So all such polynomials, whatever may be the coefficients, they are all real valued functions. And we will also have some other functions called exponential function, logarithmic function, and trigonometric functions. And we don't have that in your syllabus. So a function is to be understood as a relation between two variables, x generally named as x and y, where x is called independent variable and y is called dependent. Now, what happens when x keeps varying continuously? For example, if you have a number 2 and you have values of real numbers on either side of 2. So this region indicates the values which are lesser than 2 by a number, positive value, say h. And to the right hand side you have values greater than 2. So we generally write as 2 plus h. So h keeps varying, the values keep changing along this line either to the RHS or the LHS. So we would be interested in knowing what will happen to the value of function when x is approaching 2. So this is what we call as the concept of limit. So what is a limit of f of x at 2? This is not f of 2. You should not substitute 2 in the function, because limits are based on the values in the neighborhood of 2, in and around 2, but not 2. So, if you keep on listing values around 2, you should not substitute 2. Say 2.1, 2.01, 2.02. So, you may use your calculator to calculate all these values, but I'm just writing it an approximate value. Suppose you get 3.8, I'm giving you for an example, it's not the exact value. And this is 3.9, and this is 4.002 or 4.02. When you observe this table, you can see that the values of this function f of x, so this is value of square. I'm not writing correct value, it's an approximate value. And these are values of the variable x. So if you keep substituting the function x square and you calculate the values and list it out, you can observe that this f of x is gradually increasing towards a number, and on the RHS you can see the values are decreasing and is approaching a value, and you can easily guess the value to which is approaching is 4. So we call the limit of this function as x x is approaching 2 is 4. Now suppose I have a function f of x is x plus 1 and f of x is 2x, and this is for x being greater than or equal to 1, and this is x being less than 1. So you may think, how do we define such functions? It's up to us to define the function. You can define as many ways you like. So for this function, if you draw a graph, I hope you understand the graph of straight lines. Your y, that is f of x, is x plus 1. So it is a straight line with slope 1. If you compare this with your basics of coordinate geometry, your slope m is 1 here. So that makes an angle of 45 degrees because tan theta is slope. And you have that as 1. So theta has to be 45 degrees. So the line making an angle 45 degrees with x-axis and making an intercept at 1 on y-axis. So your line will be somewhat like this. But you can consider this function only for values of x being 1 or greater than 1. So this shall be discarded. And similarly, to the left of 1, I have defined as 2x. And you know this is a line with slope 2. So that is going to be somewhat more inclined towards y-axis than this line. And that will be up to this value of 1. So inclination will be more. And if you see, when it approaches 1, it will be approximately approaching 2. So it will be like this. And it makes an intercept 0. So from this graph itself, you can observe that when x is approaching 1 from the left hand side, the values keep ascending towards a value which is almost 2. And when you have this x approaching the same one from the right hand side, the values, the line, when you move from right to left, the values are descending and is moving towards 2. So the left approach and right approach both should lead to a common value. And that value is what we call as limit of the function at 1. Suppose this does not happen. The left and right approaches are totally different. For example, I can just modify this function a bit. See, we shall make it as f of x is equal to x and here 2x. Now, This shall be for x is greater or equal to 1. This shall be for x less than 1. Now, if you look at the graph of this function, this is y equal to x. When you have x is greater or equal to 1. So, beyond 1, you will have the graph of y equal to x, which is straight line slope 1. I mean making 45 degrees with x-axis and it intercepts 0. So, the line will be like this. And exactly to the left of 1, the graph is 2x. You can observe that if you substitute a value which is less than 1, for example 0.9, it will be 1.8, so it will be somewhere here. And the slope is much more than this. So the graph and is again with intercept 0. So this will also pass through the origin, but the inclination is more towards y-axis. Now you can see there is a huge gap between these two parts of the graph. So in this case you can easily observe when this x is approaching 1 from the left hand side, the values keep climbing towards 2, and then as x is approaching 1 from the right hand side, the values keep declining and is approaching towards 1. So this is what we call as sided limit. Left hand limit or LHL is limit x tends to 1 minus indicates direction of approach, negative region. You are approaching 1 from the negative side means you are approaching 1 from the left hand side. In that case, your value seems to be approaching 2. And the right hand limit, which we write as limit x tends to 1 from the right hand side, to be indicated by superscript plus. This function is approaching to 1. So clearly you have an observation of the limit not existing from the graph. Your graph will jump exactly at the point of discussion for limits. If that happens, you will not have the limit. So you may ask, sir, if x is equal to 1, when I substitute 1 here, I am getting 1. But we are not interested in this value, because when we discuss limits, we are not discussing the value of the function. It is totally different. We are discussing the values of the function in the neighborhood of 1. So that is what we write as 1 minus a small value h. So that takes a value to the left of 1. And a value to the right of 1 is generally indicated as 1 plus h. So h varies. Suppose h is going towards 0. Then this keeps declining. Then this value will start moving towards 1. When h is increasing here, the more you subtract, you will be more, h is decreasing again, not increasing, the value will be moving towards 1. So the neighborhood of 1 is what we are interested, not the whole function. So this region, an approximate region around 1, so the graph will be like this is a gap. So the approaches of this function on either side are not the same. So we say the limit does not exist. But in the previous case, the approaches from both directions were tending towards the same value. So in that case, you say the limit of the function exists, and that is 2. So you can have a lot of such examples. For example, you should have known this graph by this time. Signum function, which is nothing but a join of two constant functions. This will be modulus of